Hello everyone, welcome to Novel Creative Tutorials. Today we have a new expression tutorial in our series and we will have some practical examples for physical simulations by creating bouncing ball, pendulum, and springy motion using expressions as sine wave and more math expressions. So create your composition and let's get started. So after creating your composition, make sure you watch the first tutorial of this series, and this is about sine wave in Adobe After Effects using expression, and this tutorial is going to help you understand how to use the sine wave expression and also how to draw it as you see here. And make sure to visit the channel. There's a lot of useful tutorials out there, and also don't forget to visit the website if you're interested, and you can always contact me on social media here. And so now let's get back to our composition, and here I have this ellipse and rectangle. So this is how I create this pendulum here, and make sure the anchor point of this whole shape layer is in top right here, as when we're rotating, the pendulum rotates on that point. So we can basically create this pendulum animation using keyframes, but it's not what we want to do. We're going to use expression, so Alt click on stopwatch here to open this expression field, and going to create a frequency variable equal 1 for right now, semicolon, and amplitude equal 90 for now, and semicolon, and let's create a variable and call it rotation equal, and what we're going to do here is using math sine, which is defined using math capital here. And so here, as we saw in the previous tutorial, times time 2 pi, so math period pi, and let's put frequency at first here. So we're going to multiply all this, and here we're going to use the amplitude to multiply this whole thing, semicolon. And so what we're going to get here is something like this, and it's keep going and never stop on the same speed. As you see, there's same speed. We can change frequency here. So it's slowing down. You can change also the amplitude. So let's take a look here at the graph error and see how this looks. As you see, this is a sine wave, but what if we want the value change as time increase? So the value, we want it to gradually approach to 0. So to achieve that, we need basically to use a math exponential. So here, if we multiply this by math period x, so this is for exponential, and open parentheses, and let's close it. Now let's use time here. So we are going to see something weird happen. Starting slow and then speed up, start speeding, and now we can see how this really crazy going on. So let's see the graph editor again, and you would see slow and start increasing right there. So if we want the inverse of that, which is we want to divide this, so now we're going to get something like this. As you see, it stopped. So maybe we want to have high amplitude and maybe frequency of 1.5. So it stopped when time, I think 4 seconds. And let's see here, as you see the graph. So this is called double trouble. So it's increasing or decreasing as time is going. So it's approach 0 right there. So we're using exponential math expression here. And so this is a trick here. If we multiply this and put here minus, so we got the same result as we know in math. So the exponential of minus x is equal 1 divided by exponential of x. So this is equal the previous writing of the expression. And we are going now to add some decay. So to add decay here, we're going to create another variable. Let's rename this or name it decay and 0.5 semicolon, and we're going to add decay right here. Let's see the graph here, as you see. So we can manipulate here the values. So as you see, when we combine the sine wave with the decaying exponential curve, we get a decaying oscillation. It's very useful for simulating springs, pendulum, bouncing ball, and so on. So keep in mind the math expression or math exponential is very useful for these cases. So, and now we're going to see how we can actually create the bouncing ball using the same expression here. So let's go to this comp, and here I have this shape layer here, floor, and this circle here using shape layer. And so what we're going to do here is hitting P for revealing position. So here we're going to create a keyframe for this, and we want this actually to be right here. So make sure this is in contact here. Right there. And maybe around 1 second, we're going to move these right there. So we have this animation, and hold Alt and click on stopwatch to open here the expression field. And so we're going to create a variable, which is going to be frequency equal 1 for now, amplitude equal 90 semicolon, and let's add decay as well, equal 0.5 semicolon. And here we're going to name this, let's name this X for, or Y, let's name this Y, equal, using math sine, open parentheses, times time frequency times 2 time math pi. And here now we're going to make the output of this, so position, which is the position of the values here, so position values minus 0, comma, y, so this is array minus array, so the values here of x and y minus this 0, which is going to be the same as this keyframe, minus the value of y, so we're going to basically get something, as we can see. So here we're going to add amplitude, multiplying that. So here you would see the sine wave basically. Let's make these 1.5 so we can see it. And here we are basically having a sine wave expression right here, and then here just bouncing on its place. So we need to add another expression here, which is math.ebs. So it's absolute value for whatever inside these parentheses. So whatever value here, it's always going to be positive, and multiply that by the amplitude. And so now we will see the path of this animation changed. So now we have only the positive value of the sine wave using math absolute expression. We still need to do some adjustment to make this bouncing ball simulation look really good. Basically here we are using sine, so we start from there, and we can also use cosine there. So if we want that to start from the top and not from right here. And also, as you may know, a cosine wave has the same shape as a sine wave. It is just out of phase by 90 degrees. So let's leave this as it is. And now, as you see, we are already there, so we just need to create that decaying. We need to make it stop, not keep bouncing at the end. So what we're going to do is going to multiply this by math exponential up in parentheses minus decay, multiply that by time, and closed parentheses. So as you see, it's going to approach 0 and stop. So let's see here, this graph editor, as you see, start decreasing and hit 0. And of course, when we see here, we can manipulate these animations. So let's go back here to these keyframes and ease them, and here we can change these and maybe say, okay, we want it to be right there. So now we're going to have something like that. You can manipulate all of the animation. So what you need to keep in mind is that the math exponential is for decaying. That's why we use it. And as you see, we learn how to add math absolute here to get a positive value from math sine or cosine. And with the same concept and the expression, we're going to create a spring motion, and it is just about which property to use to apply the expression. Let's go to this comp. I have just this box here, and let's hit P for position, and then creates maybe something like this. So just normal animation. As you see, just like a linear animation, and holding Alt, click on stopwatch to open this field and create variable frequency equal. Let's put there maybe 3 and semicolon, amplitude equal 50, and here we're going to add decay equal 0.5 semicolon, and I'm going to create a variable of x. So x equal amplitude, multiply that by math. Let's use math cosine, and frequency, multiply that by time, to math period pi. Let's close that and multiply this with math period exponential minus decay, multiply that with time, semicolon. So here we have the value of all of this position minus open bracket, or let's actually there need to be plus x comma 0 and close bracket. Here we have a small mistake. We need to put multiply, not equal. So maybe here the frequency need to be, let's put 6 right there. So it's more springy. Let's see the graph editor to get an idea what's going on. So as you see, we have too many hits there until I approach 0 and stop. We can change the value here of decaying, so 1.5. And of course, we can create here a slider control. Let's rename this frequency, Control D amplitude, Control D decay, and just now, instead of using values there, we can just use the values from here. Oh, here we need to have 5, maybe amplitude 50, 2.5 maybe. And of course now we can keyframe our variables, maybe here 3, 90 and 3 right here. So as you see, we can have all the manipulation we want on the expression. So this was the tutorial of today. Hope it was very useful for you guys. And if you have any question, just comment and I will do my best to be responsive. And don't forget to like and subscribe for more tutorials coming soon. And thank you for watching.